Thank you.
Thanks. Not a bad day.
Isn't it?
Thanks very much.
Paul Doherty is an insurance agent, and this gives him a busy professional life. But his hobby is astronomy. Now, astronomy is still just about the only science in which the amateur can do valuable work and where his collaboration is welcomed by the professional. Paul Doherty is one such amateur astronomer. He has his observatory at Stoke-on-Trent, and I went there to talk to him. When did you actually take up astronomy?
1957, actually.
The year the sky at night started. It's only a long time ago.
Yes, yeah.
Why did you take it up?
Well, it was because of a comet that I didn't see, funnily enough.
Was that the Arran Roll?
It was, 1957.
Why didn't you see it?
Well, I didn't know the sky well enough at that time, so this made me go ahead and buy a couple of books on the sky so that I could get to learn the constellations. And I progressed to a small telescope, a 3-inch refractor, in 1959.
Well, now, of course, you've got very much further than that. You have this very fine 16.5-inch reflector
right.
in the box observatory.
That's
Paul,
right.
do show me how
Yes,
it opens.
I will
I'm
do.
intrigued.
Well, it is nothing more than a box, of course, but it serves its purpose in that it protects the telescope from the weather.
Well, it's pretty heavy, and it looks a bit dangerous as it swings back.
Yes, you need to know what you're doing with
I
it.
imagine you do. Well, it works beautifully, Paul, but one thing I do notice, and that is that the roof is still vertical, and surely that must cut off part of your sky.
It does, actually. I'm not too worried about it. The southern sky is the most important part for me, and eventually I will get some large counterweights fitted up on that to make the whole thing lighter, and eventually it will fold right back.
I see. Well, you know, it looks the most professional telescope, and yet you tell me it's made out of odds and ends. I find that hard to believe.
That's right. Everything you see on this telescope is obtained at a scrapyard.
What about the tube? I see you've got the open tube.
That's right. Well, this is bed framing, actually. It's tough steel, it's convenient, it's easy to handle, and cheap, about 5p a foot.
Well, it certainly does the job. Paul, I notice also that you're using the fork-type mounting. Well, I prefer that myself. I'd much rather have that than the German type with the counterweight. But what made you select it?
Well, two reasons. First of all, it seems a much more stable sort of mount, and the main reason is that it's much more compact than any other type. And as you can see, I'm restricted for space here, so it was the obvious choice.
Well, it's pretty massive anyway.
It is, it is.
What's it made out of?
This is just ordinary steel girder. It cost me about £2 for the whole fork. And again, I obtained it at a scrapyard, so...
And the axle itself?
That's off an old printing machine. The main polar axis shaft is a printing machine roller. And even this large flywheel here, this is a flywheel off an old printing machine.
Paul, I've also told that one of the difficulties of making a mount of this kind is the fact that it's difficult to get these big worm wheels.
Yes, they are difficult to obtain, in actual fact. They're still scrap. They come out of an old signal box. The main trouble is the worm wheel itself. I had to look around for a long time to get that sort of scrap.
There's one major difference between your telescope and mine. I have a 15-inch reflector, as you know, and it's on a fork mount, but my mounting is low-slung. Now, this mounting is high-slung, and since it's a Newtonian telescope and the eyepiece has to be in the top, it does mean you've got to do quite a lot of mountaineering.
Yes, I do. This is a great problem, but the trouble was I got so many buildings around the observatory here. The higher I could get the telescope, the better, the more sky it gives me. So it was a problem that had to be overcome.
If you hadn't had those obstructions, you'd have had a lower mounting.
Yes, I would have probably even sunk it into the floor somewhat.
Well, that makes sense. Looking at this finder, that appears to be considerably larger than mine. That must be a 3-inch refractor.
Yes, it is. It's the original telescope that I used in 1959, funnily enough. I now use that as a guide telescope.
Well, it's certainly a larger one than mine. Paul, what about the mirror? Because I know you have made mirrors yourself,
yes.
But I don't think you made that one, did you?
No, it was too big to tattle. I wanted a good one, so I decided... It was George Hole that made this one for me, actually.
Well, you certainly can't do better than
No,
that.
it's true.
But what about mounting it?
Well, it was a problem because the mirror's so thin. It's only about 1.5 inches thick. And the main rings of the mirror cell, these are pulley wheels with the hubs removed. But the mounting of the mirror in that cell was rather a problem.
Yes.
And being so thin, you get flexure problems. So this is a design I decided on. It's an 18-point suspension system based on 3 main points. And if we look at that planning in cross-section, what is in actual fact is there are 3 main bolts which come through the back of the mirror cell. Balanced on each of these 3 bolts is a bar, and at each end of that bar are 2 bolts. Now, balanced on those bolts are steel plates on which there are 3 leather pads, and spread over the whole mirror there are 18 points equally spaced, supporting the mirror equally all the way around.
So I've got the same kind of arrangement. When you were making this telescope and its mounting, what was the main difficulty you encountered?
The main difficulty, funnily enough, was to keep the rust down. Obviously, it's all made of scrap, and rust has to be removed before you can begin treating the whole thing to paint it, and that was a bit of a problem, and keeping the rust at bay even now.
I have rust problems as well. The tube of my telescope is actually wooden, but the mounting is mainly metal, of course, and I'm only 500 yards from the sea, so I can sympathise. What about your circles?
Well, I had a little bit of help with this one, in actual fact. A friend of mine has a lathe, and he cut these circles for me. What it is, it's just sandwich plastic, white sandwiched between two black pieces of plastic. And when you cut through the top black surface, the white shows through. It's quite accurate and very useful.
Well, like me, you're essentially an observer of the moon and planets. Do you use your circles very much?
Yes, I do, in actual fact, to find Mercury and Venus during the day. But this is the main circle, the right ascension circle, and this is only roughly done. But it's accurate enough, it's enabling me to find Mercury during the day, so it's okay.
Well, Mercury is a problem, of course. Venus much less so. And, of course, you're lucky. With your exceptional eyesight, I know that you can see Venus with the naked eye throughout most of the day. I so remember standing with you outside my dome at Selsey. You looked up into a blue sky and said, "There is Venus." And quite frankly, I didn't believe you until you turned the telescope onto it, but there it was.
Well, it saves using the circles, it's a fact.
But I wonder how many times I've stressed the dangers of anyone taking a small telescope or a pair of binoculars and then sweeping around the sky looking for Venus when the sun's up. Because when they do that, sooner or later, the sun's going to come into the field of view with tragic results to the observer's eyesight. It really is dangerous. Mercury, of course, is more of a problem still.
Yes. It's keeping the thing in the field once you've found it, and I do this with means of a variable speed drive. It's an electric drive, of course, and once I've located the planet, I can speed or slow the telescope down to keep up with it, and keep the planet in view all day if necessary.
Now, what about photography?
Well, I've done a little bit of photography through the telescope. The first one that I did was a photograph of Venus, which is basically a snapshot.
Well, I've liked that photograph of Venus very much. It does show the phase well, and after all, one can't see any surface detail there.
No, it just about shows what you can see. And the other photographs I've taken of the moon, these are mainly prime focus shots at very little magnification.
There's one point that strikes me, Paul, that here you are, not very far away from the centre of a town. You've got houses round you, and houses have nasty things such as lights in them. How do you get on for light pollution in the sky?
Well, it is a problem with long exposure photography, and there was one particular photograph I felt very important, and to get rid of that problem of light pollution, I decided to take a portable telescope that I've got away to a farmer's field. I asked the farmer's permission, and he allowed me to do this, and I set my telescope up and took a photograph of 20-minute exposure, in actual fact, of the comet.
What about guiding, though?
Well, this is a problem. There was no electricity laid on in the field, of course, and I had to do it by hand. And guiding by hand for 20 minutes is quite a job. But all the while I was thinking to myself, well, this is going to be a great photograph. It's worth every minute.
Well, I think it was, and it certainly was a great comet. I wonder when we'll have another one like that.
Right.
But when you're taking star photographs, well, obviously you can't do that every time. And I remember showing on the sky at night some time ago a photograph you took of Nova Cygni, 1975.
Yes, well, that wasn't taken through the telescope, in actual fact. What I did for that one was to mount a camera on the telescope and let the camera do the work on its own, and use the telescope mainly as a guide. Look through the eyepiece, keep the object centre of field while the camera took the photograph. About 15 minutes exposure.
Well, when you look at that photograph, showing the nova at its brightest, and it was quite a bright thing then, the stars appear as nice, sharp points, and that indicates that your drive must be pretty good.
Yes, it's not too bad, actually.
Now, what about clusters and nebulae?
Well, I've done a little bit of photography on those. It's mainly the bright objects, and done in this way, incidentally. The most interesting, I think, is the Andromeda Galaxy.
Andromeda Galaxy, Andromeda Spiral, Messier 31. You know, I've always been amused at the way Charles Messier, 200 years ago, catalogued star clusters and nebulae. Not because he was in any way interested in them, he wasn't, but because he was a comet hunter. And he kept on coming across faint smears of light that he thought were comets and which turned out to be clusters or nebulae. So he catalogued the nebulous objects as things to avoid. And nowadays, of course, everyone remembers Messier's catalogue, and nobody remembers his comets.
Yes, I can appreciate his problem. I do a little bit of comet sweeping myself, actually, and they can be a bit of a nuisance.
But there aren't very many of these things visible with the naked eye, and of course Messier 31, the Andromeda Spiral, is the only spiral you can see with the naked eye. And it's well on view now in the evening. I think the best way to locate it is by using the square of Pegasus. Well, Pegasus isn't particularly bright. Some people expect it to be smaller and brighter than it really is, but the square is very distinctive, and I don't think you can miss it. Andromeda leads off from it with a line of fairly bright stars. Over in the western sky, we can still see the summer triangle, Vega, Altair, and Deneb. Well, they're descending now, but Deneb at least is still quite high up, and again, you can't miss it. Over in the east, we have the brilliant star Capella, and we also have the Pleiades, the Seven Sisters, the loveliest of all the star clusters, which can't be mistaken. And, you know, when I see the Pleiades appearing in the east in the evening, I know that summer is over and winter is very much on the way. At the moment, all the bright planets are morning objects, which means, of course, that early next year they're going to be in the evening sky. And that will please you, Paul, because, after all, one of your main subjects is in drawing the planets.
Yes, that's right.
Well, I draw the planets too, as you know, but unlike you, I'm not a good artist. Therefore, what I do is to make my rough drawing at the telescope eyepiece, then turn on a dim light and make a better copy of it, and then go back and check my drawing at the telescope once more to make sure I haven't made any mistakes. But, of course, a better artist, such as yourself, can make the originals at the telescope, and I know that's what you do.
Yes, it's a method I prefer, actually. The drawing that I make at the telescope would, in actual fact, be a near-finished drawing. All it would require is a little bit more work to bring it up, but I try to finish it as near as possible at the eyepiece.
You know, Paul, taking this drawing that you made of the telescope and comparing it with the one in your actual notebook, that doesn't seem a lot of difference to me.
No, well, there isn't a great deal of difference. Of course, you don't want to have to do too much to it once you've finished the drawing at the telescope. The only thing is to enhance the detail a little bit and smooth the overall appearance off by putting this limb darkening in, which is always there and which you don't need to do at the telescope.
Well, there's plenty of detail shown.
Well, yes, and it's always nice to get confirmation of that detail. This is a photograph by Horace Dall, as you know, and the detail shown on that bears a great resemblance to the detail on the drawing. It compares very favourably. The only difference being, of course, that the centre of the planet rotates rather more quickly than the edges of the planet, and you can see the difference in the drift on those central markings when you compare it with the markings as seen on the drawing. On the drawing, they're near the edge, whereas on Mr. Dall's photograph, they're more centrally placed.
You know, Paul, the difference between your drawings of Jupiter and mine is that, in addition to having the detail accurately placed, your drawings look like Jupiter. And when I do a drawing of Jupiter, it looks like a drawing on a flat piece of paper.
Yes, well, the only reason is I put this limb darkening in, and that makes it more of a globe, but apart from that, the accuracy is there in your drawing, which is all that matters.
This drawing actually goes back to 1962, and Jupiter looks rather different then.
Yes, there's a lot more detail in the centre of the planet, as you can see there, and also the detail in this, what we call the South Equatorial Belt, which wasn't in existence when you did that drawing.
Because that's one very good reason for making these drawings of Jupiter. The detail's always changing. And of course, that's more than you can say for, well, for Venus, for example.
Well, for Venus and Mercury, for that matter, there's not a great deal of detail to be seen. Yeah. All you can see is in the nature of faint, dusky markings in the manner of this.
I note, incidentally, you lay out your observation books in the same way as I do.
Yes, this is the log that I keep. In both cases, I keep a separate book for each planet, and it's an idea I got from you, in actual fact, in the first place. But the difference is, as far as Mercury's concerned, I decided to do Mercury in a sort of a colour, tint the drawings so that you could tell at a glance which is Venus and which is Mercury. The markings are so similar that if they were both in black and white, you wouldn't know which is which. So I sort of estimated the colour of Mercury and tried to get that colour as accurately as possible. Venus, of course, is white, so I left it white.
I'm interested in seeing all the description of here, what you actually saw on Mercury.
That's right, yes, and the scene conditions, the sort of things that can affect the observation, which are quite important. The time, the date, and the longitude of the meridian of the planet at the time.
Is that the actual colour you see, Mercury?
Yes, it is exactly the colour.
Have you checked up your drawings of Mercury with the modern type charts?
Yes, the director of the Venus and Mercury section did check these drawings up with the present maps, and he said that all the markings that I had drawn did tie in with those that were actually there. So,
well, you've certainly got keener eyes than I have, because I find Mercury a very difficult object. Of course, much more on Mars.
Oh yes, much more on Mars. Mars is a much more interesting planet altogether, and a much more colourful planet. There's some colour drawings here which I've done of Mars. These were made in 1973. And this, two drawings made in one night to show the rotation of the planet. As you can see, this feature here.
Yes, Sagittarius, there he is.
That's right.
The Martian Greenwich.
That's it. Well, that's moved over more centrally on the second drawing. In 2 hours, there's a considerable drift rate there. And later on in that year, as you probably remember, there was a great dust storm.
I do indeed. There was a time when you couldn't see any markings on Mars at all.
Well, this dust eventually spread over the whole planet, completely hiding all details. And then, of course, 2 years later, at the time of that drawing, the dust had completely cleared and everything was back to normal.
And again, you've checked these drawings up with the modern type charts?
With maps and photographs taken at the time, in actual fact.
Well, I can make an effort at drawing Mars, of course, but the one that I find really difficult is Saturn. Looking at that magnificent painting of Saturn that you've got here, how long did it take you to make that drawing?
Well, it takes considerably longer to do a colour observation. Well, in fact, they're not done at the telescope. It takes about 2 hours. The observation made at the telescope about 10 to 15 minutes, but the actual colour paintings around about 2 hours because there's a lot more work involved.
Well, again, it looks there as if Saturn is floating in space. And Paul, I think people will be very interested to see just how you go about it.
Well, after the preparation of a blank, in fact, all you do is build up the detail on the planet as you would do at the telescope in black and white. You get a basic outline, and then you build that outline up to make it look like a black and white drawing. And then as far as the colour's concerned, you just put a tint, a wash over the drawing, and finally paint the whole thing round with black, and there's your result. I'll just, if you like, demonstrate how the drawing's done.
Yes, do.
The limb darkening is rather important to give it an overall globe-like effect, and it is actually there, so it is important.
It's very marked on Saturn.
Yes, it is. It's a gas planet, of course, and the light falls off considerably toward the limbs.
And having completed your disk drawing, you then had to start work on the rings themselves.
That's right.
One thing I note in the outer ring, the appearance of what's called Encke's division. Well, you know, I've found, Paul, that the appearance of Encke's division is really caused by the fact that the outermost part of ring A and the innermost part of the ring are of slightly different brilliancies, and the line of demarcation causes the appearance that we call the division.
Yes, I would agree with that now. If you would have asked me that question before I built the 16-inch, I would have disagreed, because with a smaller telescope it does genuinely tend to look like a division. But now with the larger telescope, with better resolution, it is sort of a dark zone in the rings which does separate the bright inner part of the ring from the dark outer.
It's a line of demarcation, I think.
That's right. Probably a contrast effect more than anything.
Because during the next few years, as the rings close up, the Encke division is going to get very difficult to see.
It will. Next year it will just about be visible, I would think, in moderate telescopes, and following that I think we can say goodbye to it until about the middle of 1980.
So far as the crepe wing is concerned, that has to be made to look transparent.
Yes, that'll be done finally with a heavy pencil lead inside there, so that it's almost black.
Yes.
There is also an interesting demarcation in the rings on ring B. This is the bright ring here, which is very similar to the one in ring A, Encke's division in actual fact.
It's very marked indeed, with ring B. You know, it doesn't give the same appearance of being a division.
No, it's more or less a zone again in the rings. This will all be resolved, I think, with the Pioneer probes and the Voyager probes.
People sometimes think that the rings of Saturn are uniform all the way over, but they're not. There are very delicate shades there.
That's right. There's a lot of sort of different shadings over the whole of the rings. In fact, on really clear nights, you can see a considerable amount of detail. But no really fine divisions as far as I can see at any rate.
No, I don't think these fine divisions exist at all. It was Gerard Kuiper who once looked at Saturn with a 200-inch at Palomar, and he said the only division he could see was the Cassini division, with a kind of ripple where the Encke division is meant to be.
That's right, and this is how it seems to me, and no doubt you found the same yourself.
I have indeed. Well, that's practically it, isn't it, so far as the black and white is concerned? And now that you've got the black and white drawing completed, we come to the all-important question of colour.
That's right.
Now you've finished the colour wash, comes the all-important point of blacking round the planet. And this is something I find incredibly difficult. Well, having completed that tricky operation, now for the shadows, I take it.
That's it. The shadows next, and the inner parts of the ring system there. This really is the most difficult part of the whole thing.
Yes, I can appreciate that.
Shadow of the rings on the globe, now for the inner parts.
And the globe on the ring shadow. There's this area that you're doing now, which is said by some people to be occupied by another tenuous ring. But I've looked for that ring with pretty big telescopes, and I've never seen a trace of it, and I'm very sceptical about its existence.
Well, this is how I feel. It doesn't seem as though there's anything in there at all to me.
No. Well, now that the Cassini division has been put in, the drawing is starting to look complete.
Yep. It's just a bit more work. The whole thing's got to be blacked in completely, of course, and then there's a final bit more pencil work to sort of make the thing more presentable, and then it'll be finished.
Saturn in all its glory, and as well as being a lovely drawing, it's also, of course, an authentic observation. Paul, you've got a very nice telescope and a very nice observatory. What are your future plans?
Well, the main thing that I want to do is really enlarge upon what I've already done, observe the planets in even more detail, try some measurements with micrometers, get more accurate results, and also try some photography of comets for positional reasons. And just, that's it really, more or less enlarge on what I already do.
Well, you're certainly doing extremely useful work. Paul, thank you very much, and the very best of luck to you.
Thank you.
During the last 20 years, the Sky at Night has been to many professional observatories, and we've talked to many professional astronomers. But now that we've seen Paul Doherty, I think you'll realise what the amateur can do. And remember also that his equipment is home-built. And there's one point I would like to make here, that astronomy is, above all, a science in which cooperation is essential. And that means amateur with amateur, professional with professional, and even more important, I think, professional with amateur. And observatories such as Paul Doherty's have got a really important part to play in modern science, provided they are carefully and systematically used, and this observatory certainly will be. And we've enjoyed coming here. And so, from Stoke-on-Trent, good night.